So here's our first example of doing Markov chain. It says 2 popular brands of macaroni and cheese, Smack-A-Lot and Good Eats, are sold at a grocery store. The buying habits of the customers are followed for several weeks through an advertising campaign. It is found that 20% of those using Smack-A-Lot will switch to Good Eats, and 40% of those who started buying Good Eats will switch to Smack-A-Lot. We're going to first draw a transition diagram, then find the transition matrix, and then if 50% of the customers use Smack-A-Lot at the start of the advertising campaign, what percentage will be using Smack-A-Lot after 1 week and after 2 weeks? We're going to find the answers to that. So, first your transition diagram. We have 2 states. We have Smack-A-Lot and we have Good Eats. So those are our 2 states. I'm going to call Smack-A-Lot A and Good Eats B, just to make my life a little bit easier as I am writing this out. So, our transition diagram will have 2 circles, A and B. So in the first sentence it says, the buying habits of customers are followed for several weeks during an advertising campaign. Actually, it's the second sentence, my apologies. It is found that 20% of those using Smack-A-Lot will switch to Good Eats. So Smack-A-Lot switching to Good Eats, the probability is 20%. So that as a decimal is 0.2. It says in the next sentence that 40% of those who started buying Good Eats will switch to Smack-A-Lot. So Good Eats is B, we'll switch over to Smack-A-Lot, which is 0.4. So that leaves those that choose Smack-A-Lot first, but decide to stay with Smack-A-Lot. The 2 probabilities have to add up to give you 1, because probabilities have to be 100%. So if this is 0.2, that means if they're going to stay with Smack-A-Lot, it would be 0.8. Those choosing to stay with Good Eats after having Good Eats first will be 1 minus 0.4, which would be 0.6. So there would be your transition diagram. Part B, the transition matrix. So we have P equals A is Smack-A-Lot, B is Good Eats. Those are our 2 rows. Our 2 columns, A, Smack-A-Lot, B, Good Eats. Now we just take our probabilities. Going from Smack-A-Lot to Good Eats is 0.2, so it's going from A to B. So A to B, that would go, 0.2 would go here. And then the other information we were given was the 0.4. Good Eats going to Smack-A-Lot. So Good Eats is B, Smack-A-Lot is A, so this 0.4 would go here. From our notes, the rows have to add up to give you 1. Therefore, we know that this has to be 0.8 if they choose Smack-A-Lot first and then stay with Smack-A-Lot. And then the second one's Good Eats and then stays with Good Eats, has to be 0.6. So there's our transition matrix. There's B. C. C is talking about our initial state probability matrix, so that's S sub 0. We have 2 states, so it'll be 1 row with 2 columns, A and B. So 50% of the customers use Smack-A-Lot at the start. Smack-A-Lot's A, so 0.5 would be the probability there. These have to add up to give you 1 as well, just like our notes that I put up in the previous video. So this would have to be 0.5 for Good Eats. So we need to find state 1 and state 2. So we use our formula. We're going to take S sub 0 and multiply it by P to the first power. So we'll have to get out our calculators and use our matrices on our calculators. It'd be 0.5, 0.5 multiplied by 0.8, 0.2, 0.4, and 0.6 in our calculator using our matrices button. I'll post a review of how to get those answers if you would like. Just send me an email and I can review that if you would like. That would be our first state. To find our second state, it'd be S sub 0 times P raised to the second. So it'd be 0.5, 0.5, the first matrix, times 0.8, 0.2, 0.4, 0.6, and that would all be raised to the second. So this would be the answer. This would be our second state.